let's talk about an interesting number which is nothing but called as an irrational number. So we are now talking about proving the irrationality of the numbers. So first of all, we'll talk about what is the meaning of an irrational number. As we know that a number which cannot be expressed in the form of P by Q, where P, Q are integers and Q cannot be zero, are called as irrational numbers. So what are irrational numbers? Those who cannot be represented in the formation of P by Q, such that P, Q are integers and denominator cannot be equal to zero. Those numbers are called as irrational numbers. So let us suppose we are talking about some of the examples of the irrational number. So the examples are like root 2, root 3, root 5, root 7, so goes on. All these numbers are called as irrational numbers. Moreover, we can say that a special note exists that for any prime P, if we are talking about any prime P, then square root of that particular prime, square root of that particular prime is an irrational number always. So always remember that for any prime P, the square root of P, where P is a prime, is called as an irrational number. So the definition of an irrational number is actually all clear to us, but here we are talking about proving the irrationality of the numbers, that why we call square root 2 as an irrational number. So now we will prove it that square root 2, square root 3, square root 5 or any such kind of the numbers or the irrational numbers are called as an irrational numbers with the proof. So we are proving the irrationality of the numbers now, and it is a very important concept. So let's just start with proving square root 2, that why square root 2 or how square root 2 is an irrational number. So let's just move on and talk about prove that square root 2 is an irrational number. So let's just start the solution set of proving that square root 2 is an irrational number. So let us suppose I'm talking about proving square root 2 is an irrational number. So we will prove the irrationality of this particular number with the help of a very special method which is called as by contradiction. So we are actually proving it by contradiction. By contradiction. What is the meaning of contradiction? Actually, we will contradict the thing which is given to us. What is the meaning of that? That it is given to us that prove that square root 2 is an irrational number. Means we have to prove that square root 2 is an irrational number. But we will take the contradiction of this number, means the opposite of this number. That we will suppose that square root 2 is not an irrational number. So such a process in which we always take the opposite of the given statement is called as the contradiction. So this is the method of contradiction. So here, whenever we will prove that any number or any irrational number of such kind, or we will prove that square root 2, square root 3, square root 4 or any irrational number is an irrational number with the help of this particular procedure, we always prove it with the help of a contradiction. Means we have to suppose the opposite of the statement which is given to us. So that kind of a method is called as by contradiction method. So here by contradiction, let us suppose, by contradiction method we will say, let us suppose square root 2 is not an irrational number, is not an irrational number. So if it is not an irrational number, then it means that if it is not an irrational number, it implies that square root 2 is a rational number. So if it is not an irrational number, then it is obviously a rational number. So we are supposing that, let us suppose by contradiction method we can say square root 2 is not an irrational number. So what kind of a number it is? It is nothing but a rational number. So if it is a rational number, then by the definition of the rational number, we do know that square root 2 can be expressed in the formation of P by Q. So it implies that by the definition of a rational number, by the definition of a rational number, square root 2 can be expressed as square root 2 is equal to a by b. Square root 2 is equal to a by b, where a and b are co-primes. They are co-primes. That they only do have a highest common factor, which is nothing but 1. Other than that, they do not have any common factor. So except 1, they do not have any common factor. A and B are co-prime. So here we are talking about square root 2, as we have actually supposed that square root 2 is a rational number. So a rational number can always be represented in the formation of A by B, and we have taken A and B as those numbers that are co-primes, which means that they do have the highest common factor only as 1. So let us suppose I am also writing it over here as the highest common factor of A and B is nothing but 1. Except 1, there is no such common factor. So let us suppose I am calling this equation as equation number 1. I am calling this equation as equation number 1. So let us suppose I will multiply B and root 2 together. So let us suppose I am solving the equation number 1 as A is equal to square root 2b. So let us suppose I am taking the square. Squaring both sides. I am taking the square on both the sides. So I will get the answer as A square, which is equal to square root 2 of B whole square. So let's just solve the square root of this particular number, as it is nothing but will be like 2b square. It means at the end we get the equation as A square, which is equal to 2b square. So let us suppose I am writing this particular equation as, A square by 2, which is equal to b square. A square by 2, which is equal to b square. As this particular statement implies that 2 divides A square. Let us suppose I am calling this equation as equation number 2. So from equation number 2, we can say that this expression, that is A square by 2, which is equal to B square, will definitely says that 2 divides A square. So here we can say about a statement or a theorem that we have proved already, that we know that for any prime P, if P divides the square of the number, then P divides the number itself. So here what we can say that using that particular theorem, let us suppose I'll write the theorem. By theorem, if P being a prime, P divides A square, then P divides A. So by this particular theorem, which says if any prime P divides the square of the number, then it will definitely divide that particular number. So by this particular theorem, we can say that if 2 divides A square, then 2 will definitely divide A. So we can say by using theorem, we can say 2 divides A itself. So if 2 divides a square of a number, then 2 can divide the number itself. So if 2 is dividing a particular number, so there must exist another number C. So let us suppose if I am writing it as if 2 divides A, then there should exist some C, where C is an integer. Let us suppose I am talking about C being an integer. let us say where c is an integer, because we know that if 2 divides a, then it can be represented as a by 2, which should be equal to some value c. So let us suppose c is any particular integer. So let if I'm writing this particular equation as a is equal to 2 into c, and I'm calling this equation as equation number 3. Let us suppose I am calling this equation as equation number 3. Now let's just substitute this particular equation, that is a is equal to 2c, into the equation. Let us suppose I am calling this equation as star. Now let's just substitute. Let us suppose I am calling this as star. So substitute equation number 3 in the star equation. So if I am substituting a is equal to 2c over here, so it will be like a is 2c, so it is 2c whole square, which is equal to 2b square. Now let's just solve it out. It is nothing but 4c square, which is equal to 2b square. We can cancel out the values as 2 into 1 is 2, 2 into 2 is 4, so the remaining equation will be like 2c square is equal to b square. Furthermore, we can say that c square is equal to b square by 2. So from this particular equation, let us suppose I'm calling this equation as equation number 4, we can say that 2 divides b square. From the equation number 4, we can say that 2 divides b square from the equation number 4, and using the same result or using the same theorem, that if p divides a prime p or p divides any number, the square of any number, then p divides the number a itself. So using this particular theorem again, we can say that if 2 divides b square, then 2 will definitely divides b, then 2 will definitely divides b. So if 2 divides b, and we know that 2 also divides a, so let us suppose I'm calling this equation as a double star equation, and I'm calling this equation as equation number 5. So from equation number double star and from the equation number 5, what we will get that 2 is not only dividing a, but it also divides b. It means that 2 is a factor. 2 is a factor of a and b itself. But we know that from the equation number 1, that the highest common factor of a and b is nothing but 1. They do not have any other factor except 1. But at the end of this particular solution set, we get the answer as 2 is nothing but a factor of a and b. It means that our supposition is wrong. That square root 2 is a rational number, because at the end, what we are getting 2 as a factor of a and b. But as per our supposition, the highest common factor of a and b is nothing but 1. So it means that our supposition of taking square root 2 as a rational number is nothing but wrong. So at the end, what we will say? We will say that we know that in the equation number 1, the highest common factor of these two numbers are nothing but 1, but we are getting the highest common factor or the factor of a and b as nothing but 2. It means that our supposition is wrong, and thus by the method of contradiction, we can say that square root 2 is nothing but an irrational number. So at the end, we can say as 2 is a factor of a and b, it implies it is a contradiction. It is a contradiction to our supposition. It is a contradiction actually to our supposition that square root 2 is nothing but a rational number. It implies that square root 2 is an irrational number, because our supposition is actually wrong, because we have taken the highest common factor of a and b as 1, but at the end of this particular solution, we are getting the answer as 2 is a factor of a and b, which is actually wrong. So it means it is a contradiction and our supposition is wrong. It implies that square root 2 is nothing but an irrational number. So this is nothing but called as a method of contradiction, with the help of which we can prove that square root 2, square root 3 or any kind of an irrational number is irrational using the method of contradiction. So at the end we can write, 2 is a factor of A and B. It implies it is a contradiction. I'm writing it again, as it is a contradiction to our supposition. It is a contradiction to our supposition that the highest common factor of A and B is nothing but 1. So it contradicts our supposition. It implies that a square root 2 is an irrational number. It is not a rational number. So this is all about proving the irrationality of a number using the method of contradiction. So we have to prove any number that is square root 2, square root 3, square root 5 and so goes on. If we wanted to prove their irrationality, we have to follow the method of contradiction, and using each and every step we can prove that the irrational number is why an irrational number, or we can prove the irrationality of the number. I hope this whole step of proving the irrationality of square root 2 is all clear to you. So let's just move on further and try another question.